Hello everybody, this is Mike from Cymulate, and today we're going to take a look at the Cymulate endpoint security assessment system that's in the Cymulate continuous security validation platform. And when we talk about endpoint security, it may be good to first define what is an endpoint when we're talking about this type of assessment. Endpoints are anything that runs any of the operating systems that Cymulate has an agent for. Agents just being software that acts as a kind of touch point or foothold for these simulations to be run against. And so a desktop or laptop, a server or VM, or a cloud instance that runs a supported version of Windows, Mac OS, or Linux is perfectly suitable. And we can judge the efficacy of different types of endpoint control solution sets by using this platform in this particular vector. Now, when we talk about the types of security controls that are tested by endpoint security assessments, we're looking at two main categories. First is native controls. So in the Windows world, as an example, you have tool sets like group policies in Active Directory, or software restriction policies, or user access control. The second major category is going to be first or third-party solutions that are specifically looking for malicious code, malicious content. And they could be more traditional antivirus type solutions that are looking at signature or heuristic data. And they could be tools like enterprise detection, endpoint detection response, or XDR solutions. But these are types of tools that look at behaviors. When an application is run, when something is executed, are different malicious activities taking place within the system itself. And the endpoint security assessment has the ability to look at all of these things. It has the ability to see if first-party controls are properly restricting users so that they can't do things that extend past what they should be able to do. Signature and heuristic validation, and behavioral detection. So as with many of our vectors, and you can see the endpoint security assessment vector up on the screen now, the system is designed to allow you to select a template, select a target, and select a schedule. The templates are playbooks or runbooks. These are designed to define what types of assessment objects will be run. We, of course, have many different templates that are available out of the box, and they're kept up to date by the Cymulate team as part of the SaaS platform that is the Cymulate platform. The best practice, which is the one that we're looking at right now, looks at a little bit of everything. So first-party controls, third-party controls, signature detection, behavioral detection, all of the above. You could select any of these pre-built templates and you would be able to immediately begin running an assessment based on that particular set of objects. But as with our other vectors, you can create a custom template, and that will allow you to choose what operating system you wish to run this against. And of course, you could have multiple custom templates. You could have them for different operating systems. If we choose Windows here, go to the next stage. Do I want to drop and execute the pseudo malicious files, and we'll discuss that in just a moment, directly to disk, or do I want this to be using various forms of stager technologies, in this case revolving around PowerShell, that will not do anything malicious for a period of time and then will either execute a malicious code that's packaged with them or will try to obtain additional downloads from Cymulate's repository. Now, once you've selected those options, you can move on to defining what types of execution methods will be permitted. And as with the majority of Cymulate, these are non-disruptive and non-destructive. While they will follow the paths that you have set out, they're constrained and they will not be able to cause any damage within the environment. Then you will determine what types of behaviors should be simulated. Finally, there is a database that is kept updated by the Cymulate team that contains identifiable samples of different malware. These are designed to test signature-based detection and heuristic-based detection. Now, all of these taken together produce a template. Today, we're going to take a look at a best practice template. And the best practice template, if we look to the right, you can see what that's doing. And this will also allow me to go into the types of things that we're testing and what kinds of defenses we are testing those against. So in a best practice, there are two types of test files that are used. One is those known signatured files. These are sent to the agent. The agent downloads them from the Cymulate repository in batches. Each batch is held on disk. It's written to disk and it's held on disk for 2 minutes. And during that 2-minute period, the agent will access the file, but it will not execute it. So they'll be accessed, and after 120 seconds, if they are not quarantined or destroyed by an anti-malware tool, then the agent will destroy them. So these are not being left behind. In addition to that, you could see that in this case we'll be attempting 335 scenarios. Scenarios are independent executable files. They're created by the Cymulate threat analysis team. They're built from the ground up, so they're not neutered malware or anything like that. These are files purpose-built for this explicit purpose. And each one will step through the methods and techniques that are used in a particular form of ransomware, worm, or Trojan attack. While they will step through those actions, they can't do anything destructive. Now, of course, behavioral-based tools like EDR and XDR systems can see the effects of these steps that are being taken by the scenario and hopefully will pause or stop the execution. But if they don't, it's still perfectly safe. It's not going to cause any damage or put any data, either organizational or user data, at risk. So with the Cymulate best practice, we're actually doing both of these types of testing. And with the scenarios, we're also looking at native tools, first-party tools, that would not permit things like users who should not have administrative privileges attempting to elevate. So once you've selected your template, the next step is to select a target. This test is agent-based, and so we will be aiming at a Cymulate agent that has been installed onto a device. In this case, because it's a Windows-based test, we're going agent on a Windows machine. And this could be a production device, so it doesn't necessarily have to be one that's used exclusively for testing. Because the scenarios are constrained, it won't cause any threat of damage to the environment or disruption of production operations. And then I'll decide when and how often I want to run this simulation. So we could do a one-time simulation that will either initiate immediately or at a future date and time. But I can also just as easily set up a recurring simulation, daily, weekly, or monthly, at the date and times I specify. We will just go ahead and kick this one off by hitting the launch button. That'll bring us back to the Cymulate dashboard. And in just a few moments, we will see that the endpoint security vector switches over into active testing mode. There we go. Now you'll notice again that the trace in the lower right-hand corner, for those who haven't seen previous vector videos, the trace is showing me a play-by-play of what is occurring with the agent in response to the actions being taken as part of the assessment itself. So if we look in the endpoint security history, we could see the endpoint security run, and we could see any other endpoint security runs that have been performed in the past. And if I scroll down to, say, this one, we'll bring up the report on that. And what we could see here is what we would expect in an environment where an EDR or XDR, in other words, a behavioral-based detection system, was being used to the exclusion of a signature-based detection system. And the report bears that out. If I click into this, I could see each one of these files along with their identifiable hash in multiple formats. But if, as was the case in this particular environment, if I go back one page, we knew this would happen because the system in place is a behavioral-based tool and not a signature-based tool, I'm going to be more concerned with the 3 tiles that talk about scenario execution. And we did okay. We did actually fairly well. So none of the Trojans were able to get through. Trojans representing things like botnets and other types of miscellaneous malware. But about 30%, about a third, of the worms and ransomware scenarios were able to get through. And we spoke about what happens during a ransomware scenario, but during a worm scenario, the code will attempt to probe to one other machine on the network. That machine does not have to be running an agent, but it will not attempt to propagate itself. It's simply going to confirm that the conditions for propagation exist and that exercising those conditions did not cause a response from a behavioral-based detection system. And with Trojans, this may attempt to invoke the command line or a calculator or some other activity, which in and of itself is not malicious. It's actually quite benign, but the method used to invoke it would definitely be considered as malicious. For example, if using a user account, we attempted to create and manipulate scheduled tasks, that would be something that a behavioral-based tool would put a stop to, even if it was only to run the calculator in 5 minutes' time. A user account is attempting to do something that would require super user or administrator privileges. It has no means by which it can accept a UAC prompt or otherwise provide a privileged account. And so it should not be permitted. It should be stopped either by UAC or by a third-party tool. So even though these don't cause any harm to the environment, they don't pose any threat to the environment, they are undertaking actions that are easily identifiable as threat activity and therefore should be stopped. And to the tool in Place's credit, they were stopped in the majority of cases. But we did see a third of the ransomware getting through, for example. So let's take a look and see what information we can get on that. Now, by default, it's showing everything, but again, there are filters that could be brought to bear to sort of drill down into these statistics. But the results are going to fall into one of three categories, and they follow a red, amber, green methodology for color coding. Green, which we may see if we went all the way down to the end, is indicating that something stopped the execution of this scenario file, and that it was not something that would be native to the operating system. Now, the system could figure that out, the Cymulate system could figure that out in two ways. The first way, and the most common, is that I can integrate with many different EDR and XDR solutions on the market, from CrowdStrike to SentinelOne to Defender for Endpoint, if we want to talk first party, and many others. And if that integration exists, then after the scenario is run, so in other words, we want to maintain separation of duty, the integration does not impact how the test is done. But after the scenario runs, the Cymulate platform can communicate with that EDR or XDR tool and retrieve information. What did it see? What actions did it take? So the most common reason that you would get a blocked or green status is that the scenario was stopped and there is information that directly proves that it was stopped by something other than the operating system itself. Incomplete is the next one. Those are the amber ones. This is not a bad thing. Incomplete still shows that the scenario itself was stopped. And we can even take a look at one of those. If I bring up, say, this one by going to its more info page, we could see that this scenario, when it executed, had an unknown, untrusted application touch the control panel, invoke the control panel utility, and that step was completed successfully. But when that process attempted to use that access to load a DLL, it failed. It was stopped. Now, in this particular case, we were not integrated with a particular EDR, so we can't prove that this action was stopped by a third-party tool, or a non-OS tool, to be more specific. But something stopped it, and we know that it was stopped before it could perform anything that, had it been a real attack, would have been disruptive or destructive. And so it's listed as interrupted. It's listed as incomplete. And then finally, we have the third category, which is executed completely. And these are the ones that you want to pay the most attention to. Because when something is executed completely, it means that all steps within the scenario were successfully performed. And here we could see a very similar methodology. We touched the control panel to load a DLL, but here we were successful. The method that we used to do this was not disrupted by any tools or by any OS components. We used that to load the .NET command line, which allowed us to load our .NET payload, which eventually did indeed encrypt a directory created by the agent. And we could show that. Every step has a more info button that gives you a description of the technique that was used, lets you know how it can be detected within an environment, and gives as many methods as possible for mitigating these circumstances so that it can't be used as an effective methodology in future. And We even have evidence for any step that would leave evidence behind, such as this encryption step. We're showing the directory that was created for the purposes of this test and the files within that directory that were successfully encrypted. In this case, we encrypted all 50 files. And so this is considered a failure of the security controls around that endpoint. Now, when these simulations are performed, you will also be able to get additional data if we are talking to a third-party tool. And I'm going to switch over to a different tenancy so that I can actually show you what that looks like as well. All right, so here we're looking at a different tenancy that did have some EDR solutions running in it. In this case, Sentinel-1, but this would work the same way with Defender for Endpoint or with CrowdStrike or with any of the major EDR and XDR tools. And when we look at the more info for that same type of attack, we're going to see that it completed here as it did in the other methodology, but now we could get some more information. So since we were integrated with Sentinel-1 in this case, I can click on the Events and Alerts button, and this will show me each action that was recorded by that system. Now, in this case, we could see that it has log entries, it has event details for each of the things that we expected it to have. We could see that for each one of these, but it did not trigger any alerts and it did not take any action. And that could be, as it is in this particular case, because we instructed the system to log but not to alert or to act. And if I was unaware that that settings change had occurred, perhaps the organization was having some issues with the EDR and they put it into detect only mode temporarily. That's a common occurrence. Maybe it didn't get taken out of detect only mode unexpectedly. And this would be the result. We would see that things are being logged and there's event information, there's log information for everything that the Cymulate system did during the scenario in question, but no action was taken. It may be that it was told to alert but not act, as opposed to report and not alert and not act. We're going to help troubleshoot all of these things. So these integrations are not required, just to be clear on that one point. They are not required for testing. The test will occur in the same way, regardless of if you've chosen to integrate or not. But if you do have a tool that we have an integration for, and the Cymulate sales team can let you know all the different tools that we have integrations for, then we can make troubleshooting that tool significantly easier by allowing you to see these events and other information about what the tool saw and how it acted under those circumstances. Now, of course, all of these reports, including the report on what our integration tool saw, are available offline as well. There are technical reports that are available in PDF form and in text form, typically as a CSV, comma separated value text file. In addition to that, we will have, if you did the signature-based detection testing, the malware sample testing, in other words, we will have a list of all the signatures that were used and whether or not they were detected in a text file. And if you do have a connection to another tool through an integration, we will have a separate report that just goes into what the integrated system saw and how it acted. But in addition to all this technical reporting, which you can get online and offline, we also have executive reporting. So this executive report was taken from the first system that we looked at, where it was behavioral based only. And we did the signature testing, but there was no signature detection in place. And what we could see is that it's a moderate level of risk. And that's based on the Cymulate score, which is the results of the assessment compared to NIST 830, CVSS 3, Microsoft's DREAD framework, and the MITRE ATT&CK framework. And the system combines these numbers together and creates a unified score from 1 to 100, higher scores indicating higher levels of risk. So we're at a moderate level of risk with a 53 out of 100. And that's mostly because there's nothing checking for signatures. And we, of course, leave it to each individual organization to determine whether or not that is something of concern. In this environment, we purposely told the system we wanted to test signature detection in addition to behavioral detection. So the fact the signature detection did not occur is a major concern. But in your environment, you may choose to use, for example, a behavioral only template if you are using behavioral based technologies as your primary anti malware method. And we'll spell out at a higher level the types of things that we're seeing here. So, ransomware, 32% of ransomware and worms were successfully able to execute completely. None of the Trojans were. If we look to the right hand column, we could see that in both the ransomware and worm cases, there were many steps that were completed. And so this may be, if I were to see this, I would say that most likely is simply an issue of fine tuning stuff that's already in the environment. These tools are able to detect the majority of these attacks. They just need to be tuned a bit so that they can be more effective at detecting things a bit earlier and more thoroughly. And of course, there's always a trade-off between user usability and security, and you have to be aware of that. So we want to give complete information. In this case, based on these numbers, it would be reasonable to expect that with some fine-tuning, we could lower both the left-hand side, which is the complete execution status, and the right-hand side, which is individual step execution, down to lower levels, and maybe lower the overall Cymulate score. And in this case, if I was expecting that there would be signature-based detection, I can clearly see that did not happen. And so I'd want to take a very serious look at that. But we don't stop there. We can also show things like the MITRE attack methodologies that were used and were successful, and how many of each type of technique or tactic was successful within the environment. And over time, we can even begin to develop graphs showing the risk levels over time, so that someone looking for return on investment in both tools and techniques is able to see that over time the level of risk posed by different types of malware is indeed being reduced, or if unfortunately it's going up, you'll be able to track that as well. And over time, we can begin to compare this organization to other organizations in the same industry. And that could be one of 40 different industries, from manufacturing to healthcare to finance to legal to hospitality to you name it. We've got quite a lot of them in there, and show how your level of defensiveness around endpoint security compares to others within the same industry, all done anonymously, of course. So that is a quick overview of the Cymulate Endpoint Security Assessment System. It's one of 11 different vectors that are in the Cymulate platform, and we will have videos, of course, on those as well, so we encourage you to take a look at them. And if you have any questions on determining the effectiveness of your endpoint security controls, first and third party, and you would like information on that or any of our other vectors and modules that we have within the platform, please do feel free to reach out to your Cymulate sales team. Visit us at cymulate.com. And we look forward to speaking with you and seeing how we can help you be secure and know that you're secure without any assumptions by using Cymulate. Thanks again. I look forward to speaking with all of you soon.